Okay, so this is experimental and theoretical probabilities. Again, we're talking about how all these different frequencies, they added it up and it equaled 24. So the probability of red was 8 out of 24. That was the actual experiment. But then theoretically, it had placing one block. So theoretically, it was just going to be one out of these four options. Okay. The other students in the class conduct the same experiment. Here's their results. Do you expect the experimental of the class to be closer to theoretical? They did way more. If you always do more, the more experiments that you do, the more likely that is. So yes, the more experiments one does, the closer to theoretical probability it will get. Compare the experimental from the class results to the theoretical. Are the class results closer? So we guessed, now we're proving it. So this was 116, and then 116 plus 121. Let's find out how much our total was. 116 plus 121 plus 124 plus 119 is out of 480. So red is 116 over 480. So that was, if we were to reduce it, if you can get this down. Actually, I think you could divide them by each other. So let's try that. 480 divided by 116 equals around 4. So less than 1/4. So if I do 116 divided by 6, 116 divided by 2, get 58. 480 divided by 2, get 240. Divided by 2 again, 120. Divide 58 divided by 2, 29. All right, so 29 over 120. 29 divided by 120 equals 24%. Okay, and 1/4 equals 25%. Remember how the theoretical was 1/4? 25%. So that's pretty close. Are they closer to the theoretical than Kimmy's? Yes. Because, yeah, 29, let's also look at 8 over 24. Is 33%. 8 over 24 equals 33%. And 29 over 120 equals 24%. 24% is closer to 1/4, which is 25%. So using percents, we were able to prove it. You can also prove it with your fractions. I just think it's much easier to see when you're looking at percents where you have a 24%, 25%, and a 33%. Okay, that's 337. On the back, 338. Heidi spins the spinner, records her results in the line plot. What is the theoretical probability of each outcome? So when we're looking at it, what do we think? Well, there's 5 options here, so 1/5, right? She's going to get one option out of 5. Experimental, now looking, is that when we're talking about the ones, probability of 1, she got 4. 1, 2, 3, 4 out of 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So she got 4 out of 20. The probability of 2 was 1, 2, 3, 4, 5, 6 out of 20. Probability of 3, 1, 2, 3, 4, 5 out of 20. Something interesting is that when you do probability, you put P in parentheses. Probability of 4 is 3 out of 20. Probability of 5 is 2 out of 20. So now we're showing all the different probabilities that actually happened with the experimental probability. Okay. The class conducts the same experiment and combines the results. Find the experimental based on the results shown in the table. Record the probabilities. So it's basically saying if you were to go, the frequency is 85. That is going to be your top number. 80, top number. 90, top number. 75, top number. 70 is your top number. They want to know what would the bottom number be. So that's just adding all of these up. You gotta do 85 plus 80 plus 90 plus 75 plus 70. 400. So then we put 400 for all of these. All right. Record in the table. Compare the experimental probabilities from the class data to Heidi's. So they're going from 20 to 400. So 400 divided by 20 equals 20. So we're basically multiplying everything by 20. So I have to take 4 over 20, multiply the top by 20. 6 over 20, multiply the top by 20. Okay, that's going to give us how we can compare them. 5 over 20, multiply by 20. 3 over 20, multiply by 20. 2 over 20, multiply by 20. So we've got 80, 85, 80 to match to 85, 120 to match with 80, 100 to match with 90, 60 to match with 75, and 40 to match with 70. So very different results from the theoretical and from the experimental when we added them all up. But the theoretical was 1/5. These are much closer to 1/5. Or these are much closer to 1/5. Closer to theoretical. Okay, so the larger experimental is always closer to theoretical. Always, always. They're just proving this to you. If you have a larger number, it's going to be closer to theoretical. Okay, describe an event involving a number cube, which with the experimental probability and theoretical are both equal to 1/3. I'm just thinking of multiplying by 10. So 1/3, doing it 10 times would be 10 over 30. So it would be the theoretical is theoretical of rolling two numbers, because I'm thinking this is 1/3, right? Which is also 2 out of 6. Of rolling a dice with 6 numbers and rolling a 1 or 2 is 2 out of 6, or 1/3. The experimental, right, with a dice, dices and number cubes are usually good for getting the same experimental and theoretical. The experimental of rolling a 1 or 2. Okay, so if we actually were to roll them, I would still get 2 6, or if I roll it 30 times, 10 30ths, which are both 1/3. So then they would still be the same. All right, and that is going to be page 337, 338.